Okay, hello everyone. Thank you for taking the time to join our webinar today. My name is Adi Goldman. I'm the Product Marketing Manager at RADWIN. And today in the webinar, we want to review the connection between emerging seaport automation application and the wireless broadband connectivity. During the webinar, we will talk about port automation, challenges and requirements, fixed applications and mobile applications. And we will have a short review also of ship-to-pier or ship-to-shore connectivity and the challenges behind this type of application. We'll also have a look at RADWIN wireless solution for the port application. If any questions during the session, please use the tool for writing them down. I hope I will be able to answer during the session. If not, I will send an email personally and reply on the questions. So let's review what I'm going to present here today. So we'll start with a high-level introduction of RADWIN for those of you who are not familiar with us, following up with the first application, which falls under the port automation. We'll have the application, benefits, and solution. The second application, as mentioned, in the ship-to-shore connectivity. Again, we'll see the application and the benefits and the solution that we can bring to it. And we finalize it with some case studies already implemented of both applications. So briefly about RADWIN as a company, for those of you not familiar with us. RADWIN is a leading global provider of broadband wireless solution, focusing on sub-6 unlicensed spectrum. The company, sorry, I think I was disconnected for a second. The company produced a carrier-grade radio solution for more than 20 years, with more than 1 million units already deployed worldwide. And our solution are deployed in over 170 countries and are certified by tier 1 carriers like Verizon, T-Mobile, Telefonica, and others. RADWIN solution include the point-to-point and the point-to-multipoint solution that are targeted for service providers, providing cellular and IP backhaul, as well as enterprise and residential broadband access. In parallel, we have a radio solution for private networks, for vertical industries. We'll touch that next slide. And we have a transportation solution, including fiber in motion, broadband access solution for vessels on the move, and the TerraBridge, our millimeter wave solution for intercarriage connectivity and data offload. We have the smart node to simplify deployment of smart cities and telecom projects, as well as sometimes in ports. And we have our OSS solution, including RPlanner, SET, WinDeploy, WinTouch, and WinManage. We have a partnership with Facebook to develop broadband wireless solution in millimeter wave, 60 gigahertz. We also have formed a partnership with Microsoft to develop a broadband wireless solution in the sub 1 gig, which is also known as TV white space for rural areas. And these partnerships, obviously, with global industry giant, provide recognition of RADWIN's technological capabilities in development of innovative broadband wireless solutions. In terms of the applications or verticals where we are playing, it's as you see on the screen, the ports, smart cities, oil and gas, utilities, mining, public transportation, and we'll start this session with the port application. So when talking about port automation, can be defined as the use of integrated technology to develop intelligent solution for efficient control of traffic and trade flows on the port, thereby increasing port capacity and port efficiencies. Container ships makes about 9,000 port calls, and the vehicle vessels about 1,000 port calls per week. This means workers at the port worldwide load and unload more than 10,000 liner ships stops per week, which makes it an average of about 2 port calls per week per ship. Currently, most of the ports across the world have technology integrated for some extent. However, there is an increase in the number of smart ports thanks to the global initiatives and the high growth of maritime trade. The degree of automation per port differs from port to port, and it depends on the capacities of the port, the location, the amount of cargo it handles, and its economic value. Port automation should also be taking into consideration the need of the shipping companies whose cargo is actually being transported across the seas. So technologies has been immensely helpful to improving the order and operation productivity of the ports. Port automation is about remote and autonomous operation among other, and this is done to stay competitive. Terminals need to look at ways to improve productivity, and the most cost-efficient way is to implement software and the remote connectivity machines and devices. Automated vehicles like remote monitor the AGVs, RTGs, ship-to-shore cranes, CCTV, OCR, and many others collect huge amount of data that needs to be delivered in real time to the control room and the operating personnel in the port. Communication between the vehicles and the port operation center, as well as vehicles and their environment, should run on a reliable wireless network. Data, for example, control and monitoring signals should be transmitted seamlessly without loss, latency, or with low jitter in a very harsh port environment. And traditionally, the information exchange within the team relies on verbal communication over radio or even information on paper. This way of working is a potential source of inefficiencies and error. And any change in discharging or loading can result in loss of time because the task lack efficient way for communicating the changes in the planned work order execution. And when the whole team has access to the same information at the same time at all time, the potential of errors is significantly reduced. Operational data and diagnostic information need to be transmitted also in a reliable way to allow maintenance personnel and port operator to efficiently attend operational issues in real time and to solve the fault quickly. Automation allow also bringing more goods through the same footprint than a manual facility, with faster truck turn time, and in some cases also showing up to 90% reduction in emissions. CCTV and IP cameras integration allows remote monitoring of video cameras in real time, which helps improving the site security and the employee safety. In addition, there are cameras installed on cranes to monitor automated loading and uploading processes, or for inspection, for example, and also to manage the crane operation that requires constant video transmission. When we talk about ship to shore, so logistic management with IoT comes into action here. And during the ship to shore delivery of cargo transported by the ships, use of both manned and unmanned cranes for uploading is currently very common. Across the world, there are only few dozens of terminals that can be considered fully automated when it comes to container transportation. And automated cranes are used to deliver the containers from the ships to the port by means of unmanned horizontal transportation or unmanned yard cranes. And these are later classified by type of cargo and stacked accordingly in the inventory. These container handling systems are stable, predictable, and highly efficient. That's why they are getting more and more common. And as the cranes are controlled by a computer, the planning and execution process become extremely smooth, achieving the required outcome as I mentioned before, in very time efficient manner. The other very common application that we see in port automation is rubber-tyred gantry cranes. These are most popular equipment for container stacking at the terminals around the world, especially where high capacity stacking and optimal movement are key requirements in the port. The automation levels of those depends on the requirements, and it goes from semi-automated to highly automated. RTG combine high stacking density with perfect movement flexibility, making it a great fit for different size of port, medium size to larger terminal. And the flexibility of RTG operation comes from the capability to change the operating stack. The main reason to choose an RTG setup compared to other terminal concepts include simplicity, as well as relatively low capital expenditure and infrastructure cost for deployment. The rubber-tyred cranes can be moved to a different area of the terminal, and if additional handling capacity is needed at another area, which makes it very flexible and operational efficient. Valuable benefit of automation, of this type of automation, is that it enables the terminal to keep operation running for 24 hours a day without significant cost increase or the need to carefully optimize manning level. The reason for that is the cranes operate without a driver. Operator sitting in a control room can handle multiple RTGs from one desk, which saves also on the shift transition time, as well as a more comfortable work and safe environment for the operator himself. But not only that, provides greater safety, and this is one of the major contribution in all automated solution. And with modern technologies coming in, high level of automation is also available wirelessly, and that is also the case here with the RTG cranes. The machine onboard system guides the crane to its next position, either in a semi-automated mode with the driver feeding in commands manually, or it can be done automatically with the pre-planned software. Safety can be also further improved with additional system preventing accidents, such as anti-track lifting and stack profiling. It might goes without saying, but it's crucial to have wireless communication with RTG that is stable, reliable, and have flawless 24/7 operation. AGVs, automatic guided vehicles, is a vehicle that is driven by an automatic control system that serves the role of the driver. Sensors, usually on the road or infrastructure, along with onboard the vehicle, provides measurement about the location and the speed of the vehicle, which are used by the automatic control system to generate the appropriate commands for the throttles or brakes actuator in order to follow certain position and speed trajectories. The AGVs are considered to be the most flexible type of material handling system. They have a lot of size range, from small load carriers of a few kilograms to over 125-ton transporters. And the vehicle's working environment varies from small indoor operation to huge port operation and even elsewhere in other industries. The AGV system consists of the vehicle onboard controller, management system, communication system, and navigation system mainly. The onboard controller is responsible for initiating the startup and shutdown procedures, and it manages the propulsion, the steering, the braking, and other functions of the vehicle. It also monitors and detects any errors and issues that are necessary to be corrected. The management system deals with the planning, scheduling, and the traffic control. It is responsible for optimizing the vehicle utilization, giving transport orders such as dispatching and routing, and tracking the material in the manufacturing environment. The communication system is used to transmit the data from the AGV to a central controller and vice versa. And the information is consisted of the positioning and the status of the vehicle, the position of the currently assigned job, and potentially or possibly also the position of the next scheduled job. The navigation system provides guidance and navigation to the AGV in the operating environment, and the guidance and navigation could be based on a fixed path or a free path approach. In the fixed path approach, the AGV is restricted to follow a fixed path, and there is no flexibility to change the guide path. Examples of fixed path include the rail tracks or embedded wires or any of guideways. And in the free path method, the path of the AGV can be changed dynamically. So the system is autonomous and is capable of detecting the path using online information, also obstacle detection and collision avoiding system, which are on board the vehicle. All those onboard systems that I just mentioned need to transmit data back to the control center to monitor the AGV operation and vice versa, and to make sure it has no fault, no maintenance need, or even if it has maintenance need, to be aware of it and make sure that it is handled on the spot, and that the vehicle operate properly and as planned. More advanced AGVs that are seen today can be also equipped with the robot arms or grippers and perform robotic handling function. So there is an advancement from every aspect all the time. In terms of wireless infrastructure, so here is just an example of use case at a typical port location. Obviously, this is a schematic drawing. What we can see is that alongside providing high-speed backhaul between fixed location, we also have the need to provide the same reliable high-speed connectivity to locations with no fixed method of access. And our product, RADWIN products, can be used for multiple shared deployment scenarios. And this is important in order to provide seamless and total flexibility for control functionality. Drilling a bit on the RADWIN solution as a general, so RADWIN provide carrier gate solution for the harshest of environment, both in build quality and in operation. Using our complementary range of product, we can deliver ultra high capacity to meet the demands of the latest camera and control system technologies as well. And the automated system require low latency with fast switching time to ensure smooth operation with high availability. So we have point-to-point and point-to-multipoint solution, as well as our fiber in motion, the transportation solution that is targeted for the vehicles themselves. RADWIN Jet platform allows completely flexibility to scale across multiple deployment use cases. The Jet Duo, in particular, provide increased total capacity to meet today's demand for highest total bandwidth. This is achieved by a dual carrier radio to maximize the use of available RF spectrum, providing up to 1.5 gigabit per second of total capacity for uplink or downlink. Whilst regular point-to-multipoint solution can be used in similar ways, the energy transmitted from the antenna is spread across the entire coverage area. And as a result, the sector loses performance as is subject to interference. With our integrated beamforming antenna and technology, we are able to provide increased immunity against RF interference. The jet beamforming antenna concentrates the transmitted RF energy toward the relevant target location, therefore increasing the range, the total capacity, the robustness, and overall reducing interference in the network. With our bi-beamforming technology, you can also benefit from the same performance on the uplink to provide maximum available bandwidth to meet the requirements for multiple camera in a single location with up to 90% uplink. And with our Jet Pro and Jet Duo solution, we are able to provide seamless roaming between locations. For example, as an RTG moves across its designated area of travel, the nomadic roaming functionality within the equipment mounted on the crane can seamlessly switch between locations to provide max range, max coverage, and optimal bandwidth. This is also a similar case for vessel and ship connectivity when moving between port locations. Showing here some of the highlights of our fiber in motion mobility solution. As you can see, these are ruggedized products designated for the transportation segment, oriented to operate in harsh environment with wide coverage area and high throughput of up to 750 megabit per second. The solution allows guaranteed bandwidth per vehicle, making it highly reliable and providing smooth operation with no downtime. A little bit about the ship-to-shore connectivity, delivering broadband wireless connectivity for data offload, as well as crew welfare and passenger Wi-Fi. Container ships today, oil tanker, general transport, ferries, passenger ships, and others have onboard sensors and systems that are collecting data throughout the cruise that requires offload and update as the ships arrive to the docking port, to the stationary port. As this ship spends any time between a couple of hours to a couple of days at the port proximity, crew member and passengers sometimes that remains on the ship require broadband connectivity. While cruising, usually a satellite connectivity provides the crew with some wireless connectivity for the operational needs. As this type of connection is highly expensive, this usually does not serve the crew or passenger or even offered at a high price, or offered, sorry, at a high price and with low bandwidth, less than 5 megabit per second. Now, having said that, while docking or parking or waiting to dock, crew and passenger are looking to enhance their connectivity to allow both the operational data offload, but also their personal data offload or media download, as well as connecting with family and friends. So today available solution provides some challenges that need to be addressed. Satellite connectivity, as I mentioned, is highly expensive, especially as bandwidth requirement increases. And using a hard drive or a USB stick to offload the operational data is not very efficient, and it's open to human errors and also is time consuming. RADWIN comes here to provide a reliable connectivity with carrier wireless broadband solution that are ideal for ship-to-pier connectivity need. The system seamlessly integrate with satellite communication on the ship and the fiber connectivity on shore to deliver a reliable hybrid network that connects your ship to the port as it arrives to the port proximity, disconnecting it from the satellite, and connect back again once the ship leaves the port. So this type of integration allows the ship operator to efficiently update and offload trip data, as well as enhance the crew safety, welfare, and passenger high-capacity Wi-Fi for the time at the port. RADWIN can provide a unique, automated, and robust permanent solution for connecting vessels to the port network with no requirement for a third-party application such as VPN or additional gateway requirement. The vessel can be treated as a PC connected directly to the network with high availability throughput of up to 100 megabit and sometimes even more. Our solution factors changes in tidy heights, reflection, and other environment challenges to provide the best assured connectivity and capacities. The return on investment from a shore to vessel or a ship to shore deployment is very short, often replacing costly satellites connection fees while at the port again. When comparing our connectivity solution with a typical VSAT connection, it is clear to see some of the key benefits. Often vessel operators have to send a technician on board when docked in port to update the vital system due to low bandwidth and high latency. Using our solution, we are able to provide fast connectivity with low latency and avoid such cases. In addition, VSAT is typically an expensive solution for high data transfer of vessel system update, cargo inventory transfer, not even to mention the crew access to media downloads, communication. And with the RADWIN solution, there is no additional cost for data transfer, therefore less restriction. Our solutions can be integrated to work alongside existing VSAT or cellular connectivity and connected using existing traditional aggregation equipment. The solution can also be tailored to provide coverage to vessels before they even enter the port location and deployed to ensure flexibility and roaming capability between port location using our nomadic technology. Wanting to show you some of the deployments that we have had along the last couple of years. So you can see here the connectivity of a port to allow monitoring the container movement and also for security and the crane operators. So you have a look here at the base station and you can understand from this picture the size of the port here that we cover. Another application, as I mentioned, mobile video transmission from the moving crane, in this case, the RTGs that are moving on rails, making sure that efficiencies and operational are as needed. Went to the Hong Kong port, installing our equipment for video surveillance, as well as for supporting the port authorities in controlling the movement and the operation of the port. Here it is from a lower image. You can see a radio and omni antenna fixed to both sides of the crane to assure 360 degrees video surveillance as the crane moves. Among the 10 largest ports of the world, Qingdao port is the first full automated container port in the world and probably the biggest one in Asia today, or the second one. After 1 year of operation with port automation, the port efficiently now have more than 40 containers per hour, which already broke the world record. The application for us is to provide mobility access to about 40 AGVs with a couple of dozens of base stations covering the entire port and allowing a smooth movement of the vehicles themselves. The user here made an AB network redundancy solution, both in terms of the coverage of the base station, but also 2 mobile units for redundancy per AGV, allowing or making sure continuous operation in any case. The system was installed and optimized during 2016, and the system providing continuously stable performance 24 hours every day in those last couple of years with this application. Port of Shanghai, also in China, one of the biggest one. RADWIN products now been widely deployed in the Shanghai East Container Terminal and the Qingdao Container Terminal of SIGP. We mainly provide here crane remote control solutions, as you can see here. So operator operates multiple vessels together. Additional point here is that the network mainly used to transmit the high-definition video surveillance of the cranes and business data of voice over IP systems, and as well as PLC signaling services. And the operator, as you see on the central image, can sit in the NOC and operate the crane in a very safe and comfortable environment. Some case application on the ship-to-shore connectivity. We can see here the connectivity of ferry vessels that are traveling along the Norwegian coast, providing here internet access for passenger with 20 megabits per ferry vessel. You can see the long route and the overlap coverage between the base station on the two sides of the land. So there is a automatic transfer between the base station as the ship moves from one side to the other. Additional images of from the vessels themselves and also from the base station. Additional story around Mersey ferries in Liverpool. Provide high capacity data connectivity for control systems and weather systems and others. You can see here the base station located in the port. We have overcome about 10-meter high tide or low tide water high differences with a very high installation location compared to the ferry height. So that was with up to 6-kilometer coverage per base station. And we have provided concurrent ferries at any given time with 8 megabits per second each. Another application from that aspect is the CalMac unified communication. There are over 30 vessels providing both passenger but also vehicle and shipping services. And it routes from the Scottish mainland to the islands and the highlands, including all the names that you can see here, like Mull, Lewis and Harris, Skye, north and south east. There are currently 25 routes. You can see here again the coverage of the base station between the two land locations, just as an example. There are 24/7 available WAN and LAN on all fixed site and vessels. And the technology is an enabler for sustainable growth. So we have a 7-year contract here. So that brings us to the end of our session here today. I appreciate and thank you for the time being here with us. If any questions, please feel free to contact me and I will be happy to provide you with any additional information needed. And looking forward to see you in one of our next webinars. Thank you very much.